Good morning, everybody. Today we're going to talk about trigonometric equations. So just like we used to do in Algebra 1 and Algebra 2, we're going to solve equations. Well, we're going to do that with problems that have trig functions in them, like cosine theta is 1/2. Now, you're really going to want to have your trig chart with you, so I would go and get that trig chart out. Of course, it looks like this. And we're going to go ahead and solve this. So we've got cosine theta is 1/2. I need to get rid of that cosine to get the theta by itself. So how do I do that? I arc cosine both sides of this equation. Okay, so that's going to make this go away. I'm going to have theta here, and then that's going to equal the arc cosine of 1/2. Now, we are going to use all the values on our trig function, or on our trig chart, to find all the solutions to this. There's probably going to be multiple solutions. Okay, so we get our chart here, and we go find cosine of 1/2. Well, cosine of 1/2 here is pi over 3, but it's also down at the bottom of this chart. Cosine of 1/2 is also 5 pi over 3. So I'm going to get two sets of answers to this. Okay, so when I write that down, theta is going to be pi over 3. Theta is also going to be 5 pi over 3. Now, there's two ways that you can see these problems. Sometimes they'll just give them to you like this. Find all the solutions. Well, there is an infinite number of solutions to this problem. Sometimes they will write an additional thing out here that says, find all the solutions between 0 and 2 pi, or something like that. Or they might write it like this. Okay, now you got a limited number. Now you're just going to find them all. But this one didn't have that, just said find all the solutions. So I have to find an infinite number of solutions. How in the world do I write down an infinite number of solutions? Well, I do it like this. I write theta is pi over 3 plus 2 pi k, and theta is 5 pi over 3 plus 2 pi k, where k is an integer. Okay, now what does that mean? Well, what that means is, remember, cosine has a period of 2 pi. So I'm going to get the same answers every 2 pi, right? So if I look at the graph real quick, okay, and this is my pi over 2, pi, 3 pi over 2, 2 pi. Okay, then this would be what, 5 pi over 2. And this would be 3 pi, and then this would be 4 pi, and this would be 7 pi over 2. Okay, so I'm kind of running out here quite a ways. And cosine is going to look like this. Okay, so pi over 3 is like right here. There's an answer. And then 5 pi over 3 would be like right here. Okay, now if I take my pi over 3 and I add 2 pi, guess what I get? I get, whoops, I don't go that far. I'm going to get this answer right here, which is the same thing. And then if I take 5 pi over 3 and I add 2 pi, it's going to take me over here. It's going to give me that answer right there. And so what I want to do is I want this to be an integer, so it can be any whole number, whether it's positive or negative. It'll move me anywhere on this chart that I want to go, and it will give me those answers. So I'm going to get one set of answers. It's kind of the blue ones here every 2 pi, and then the orange ones I'm going to get another set of answers. So this is my complete solution right here. Okay, next up. See, this one tells me I only want the answers between 0 and 2 pi. So I've got 2 theta. I'm gonna rewrite this so it's a little easier to read. 2 sine theta plus the square root of 3 equals 0. So I'm going to solve this just like I would anything else. I'm going to subtract square root of 3 from both sides. So I get 2 sine theta is negative square root of 3. Now I'm going to divide by 2. Okay, so sine theta is now negative square root of 3 over 2. Now I'm going to arc sine this. Okay, so theta is going to be the arc sine of negative square root of 3 over 2. So now I go to my chart, my trig chart, which I've got right here. And I go find negative square root of 3 over 2 in, let's see, this is a sine problem. So negative square root of 3 over 2 is right here, 5 pi over 3. And it's 4 pi over 3 right here. So I've got two answers here. So then theta is going to be 4 pi over 3. And it's also going to be 5 pi over 3. Now, if I add 2 pi to either one of these, I'm going to be beyond 2 pi, right? So I only want the answers between 0 and 2 pi. If I subtract 2 pi from these, I'm going to be below 0. So this is all the answers that I have that's in that range. Okay? There's an infinite number of solutions to this problem, but I only want the ones between 0 and 2 pi. Okay. Now, what about this one? Solve the equation sine 2 theta is 1/2. I want only the answers between 0 and 2 pi. Okay, so first thing that I would do here, let's rewrite it so it's a little bit bigger and easier to see. Okay, I'm going to arc sine both sides of this thing. So I get 2 theta is the arc sine of 1/2. So I'm going to go find out what's the arc sine of 1/2. So I go to my chart. Arc sine of 1/2 is, here's 1/2, pi over 6, and also 5 pi over 6. Okay, so we'll flip back here. 2 theta is going to be pi over 6, but 2 theta is also going to equal 5 pi over 6. So now I got two equations that I got to solve. And then I need to put my plus 2 pi k on here, even though I don't want to go beyond 2 pi, but you're going to see that the period gets changed here. This might give me some extra solutions. So I want to add that on there because the next step on this is to divide by 2 on both sides, on both these equations. Okay, so what happens here? I get theta, and pi over 6 divided by 2 is pi over 12, plus 2 pi k divided by 2 is pi k. Over here, I get theta equals 5 pi over 12 plus pi k. All right. So again, I want all the answers between 0 and 2 pi. So here's my first one is going to be pi over 12. Now, if I add pi to that, I want pi to be in twelfths because this one's in twelfths. So that's 12 pi over 12. So if I add 12 pi over 12 to pi over 12, I get 13 pi over 12. Well, guess what? That's less than 2 pi. So that's another answer to this. 13 pi over 12. Now, if I add another 12 pi to this, I get 25 pi over 12, and that's more than 2 pi. So that's all the answers I'm going to get out of this one. Over here, I get 5 pi over 12. And then if I add a 12 pi over 12 to that, I get 17 pi over 12, which is also less than 2 pi. But if I add another 12 pi to that, now I'm at 29 pi over 12, and that's too big. So this one has 4 solutions. Usually I like to write them in order, so I'd put pi over 12, and then 5 pi over 12, then 13 pi over 12, and 17 pi over 12, but you don't have to do that. Okay, solve the equation. Tangent of theta minus pi over 2 equals 1. Tangent of theta minus pi over 2 equals 1. Okay, first step, get rid of the tangent. So So I'm going to arctangent both sides. Okay, so I go find what's the arctangent of 1. So it's going to give me pi over 4. It's also going to give me 5 pi over 4. So I'm going to get 2 sets of answers here. So I got to rewrite it as 2 different equations. So theta minus pi over 2 is going to equal pi over 4 plus 2 pi, or not 2 pi k. The period of tangent is just pi k. And then theta minus pi over 2 is 5 pi over 4 plus pi k. Okay, now what do I do next? I'm going to add this pi over 2 to both sides. So theta is going to equal, that's going to be 3 pi over 4 here, plus pi k. And over here, when I do this, I'm going to get theta is going to equal, let's see, that's going to be 7 pi over 4 plus pi k. All right, so I want all the answers between 0 and 2 pi again. So the first one's going to be 3 pi over 4. Now if I add pi k to that, that's 4 pi over 4. It's going to make that 7 pi over 4. Well, that just gives me these answers here. So these are going to give me the same sets of answers. So 7 pi over 4 is my next one. If I add another pi to that, that'd be 11 pi over 4. That's too big. If I subtract 4 pi over 4 from here, I get negative pi over 4. And I don't want a negative, I only want between 0 and 2 pi. So this has 2 solutions. Okay, next up, solve 4 cosine squared theta minus 3. Okay, so probably you figured out the first thing I want to do to this is add 3 to both sides. So I'm going to get 4 cosine squared theta equals 3. My next step would be to divide by 4. So cosine squared theta is going to be 3/4. Now I need to square root this thing. Okay, so what do I get? Over here I get cosine theta equals, this is going to be the square root of 3 over 2, but it's plus or minus. That's important because it gives us a whole nother set of answers. Okay, so the next thing I want to do is I want to arc cosine both sides. Okay, so now when I go look at this on my chart, I need all the times where I'm going to arc cosine plus or minus a square root of 3 over 2. So theta, let's see, I get my chart. So arc cosine is going to be pi over 6. It's going to be 5 pi over 6. So there's 2 answers. Let's get those down before. So pi over 6 plus 2 pi k, right? Theta is going to be 5 pi over 6 plus 2 pi k. All right, then I got to get the rest of them. So 7 pi over 6 and 11 pi over 6. That's my other 2 sets of answers. So this is going to have 4 sets of answers. 7 pi over 6 plus 2 pi k and 11 pi over 6 plus 2 pi k. Okay, now Do I really need the 2 pi k in this problem? No, I don't, because I only want the answers between, oh, nope, I do. Oh, no, I want only the answers between 0 and 2 pi. So if I add 2 pi to any of these, I'm going to be outside that range. So my answers then are going to be, oops, theta is going to be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. 4 answers. Okay, this one I got to use I got to solve using a calculator because 0.3 is not on my graph here, and this is going to be a little bit tricky. It's going to give you one answer really easy. So if I want to solve sine theta as 0.3, I just arc sine both sides, and I get theta is the arc sine of 0.3. Now make sure you're in radians. Okay, always double check that. Okay, arc sine, so second sine, 0.3. Hit enter. Okay, it gives me an answer. And that answer is 0.304. Now, if you remember, on most of these, we had 2 sets of answers at least, right? So your calculator will only give you one answer. So you got to figure out the other one. So let's do a sketch here of sine. And here's 1, here's -1, and then 0.3 is like right here, right? Okay, so what does sine look like? Sine's going to look like this. Okay? So 0.3, just a horizontal line right there. So I'm going to have an answer here and an answer here, plus every 2 pi k, right? So I got to figure out, I got this one. This is 0.304 right here. What's this one? Okay, I'm going to use symmetry to figure this out. Now remember, this is pi over 2, this is pi right here, 3 pi over 2 and 2 pi. So pi, I can write that as 3.1415. Okay, and if I look here, this distance is 0.304. Well, guess what? This distance right here is also going to be 0.304. So I'm going to take 3.1415 and I'm going to subtract 0.304 from that. And I get 2.8375. That's going to be my other answer. Now, since it didn't say give me all the answers between 0 and 2 pi, I need to have all the answers. So keep in mind that the period of this sine is 2 pi k. So I'm going to go plus 2 pi k and plus 2 pi k. And then I'm going to add on here where k is an integer. And now I've solved this thing. I've got all the answers right in there. Now, if this was a cosine problem, you're going to use symmetry on that too. Or if it was negative, you would use you'd use the distance between. Like if I had a negative answer here for sine, I would want to figure out, okay, what's the distance from pi to my answer, and then from 2 pi back to my answer right here. Okay, and cosine, it works the same way with cosine, except that cosine's graph is a little different, right? So cosine is going to look like this. So here's 2 pi, and there's pi. So if you had a positive answer, something right here, well, you're going to figure out what's this distance right here. Well, that's the answer you're going to get on your calculator. And then you're going to have to take 2 pi and subtract that same number from here to find that answer right there. And if it was negative, you would get this answer, and then you would take whatever this distance was and add it onto pi on this side. So you got to be able to use some symmetry here. Okay, so I got a few problems for you here. Okay, lesson 5-7, and good luck with that, and I will see you next time.